was originally from New York, but I did work in Chicago for a while. I worked in DC for a while. I was a fire marshal at the Pentagon for a while. And through those different things, I've been able to see how different markets approach it. And as a kind of an emerging industry, in my opinion, it can be very different depending on where you are in the country.
Hey everyone, thanks for listening to another episode of Buildings 2.0. Today I'm speaking with Brandon Finzel, principal and founder of FLINT Fire Engineering. Brandon, thanks for chatting with me today.
Thank you for having me.
Give us the 30,000 foot view. So fire life safety, where are we at today in the industry? What should we know today versus where it might have been 10, 20, 30 years ago?
You know, the interesting thing for fire and life safety is, as a profession, I guess, it's kind of young to some extent. I mean, obviously, fire and life safety, go back to ancient Romans, whatever. People have been doing something to, treat for fire hazards for a very long time. But unlike mechanical engineering, other engineering disciplines, there wasn't a more formal engineering discipline around fire protection engineering. And so kind of historically recently, I actually worked with one of the people that was one of the, I think, student number 4 of one of the college programs. I went to Worcester Polytechnic Institute, which is in Massachusetts. They have a master's degree in fire protection engineering, so they have a program around it. There's only 2 other schools in the country that offer an engineering degree in fire protection. So Maryland University and Cal Poly. There's some other fire science and fire engineering programs that are starting to emerge now. But that Maryland WPI, I mean, it's 30, 40 years in the making, which is very different than 100 years or something like that as far as progression. So, and still in many jurisdictions, New York City is one of them as well. It's still kind of an unknown profession. There's segments of it, so you might work with a sprinkler designer or they'd say a fire protection engineer on their resume, but they're designing sprinkler suppression systems for buildings. But they don't really touch fire alarm or smoke control or any of the other things that I would think of as a fire protection engineer. You might have someone that does fire alarm design. They're part of that community of fire and life safety, but they're not a fire protection engineer that's looking at it, holistically. So there's only a handful of people that are really looking at it that way. That's really, I think, the next phase of the profession. You'll see, depending on jurisdiction, DC is a lot more holistic, Washington, DC, because Maryland University is there and graduates a lot of people into that community. So the authorities are more educated. Similar in the Boston area because of Worcester Polytechnic Institute. And you have a community there that approaches fire and life safety a little bit differently. But even in New York City, I found, I came to New York City, I guess, oh gosh, it was a while now ago, but, over a decade ago. I was originally from New York, but I did work in Chicago for a while. I worked in DC for a while. I was a fire marshal at the Pentagon for a while. And through those different things, I've been able to see how different markets approach it. And as a kind of an emerging industry, in my opinion, it can be very different depending on where you are in the country. I've had colleagues over the years that work in different jurisdictions go, well, that's how you do it in New York City? That makes no sense to me. Or vice versa. You go to, some other jurisdiction and they go, like, you guys don't do anything for this? So I think it's a newer profession. And I'm excited to kind of see kind of where it goes. And I really think holistic view of fire and life safety. So using all the tools in our toolbox to protect occupants from hazards of fire. And that's growing too, because it's fire protection engineering, but it's really emergencies. It's broader, it's explosions, it's, any hazard that's going to cause people to need to move out of a building, get safe, even into the wildfire environment, all these different things, understanding the behavior of fire and other emergency and all hazards, we kind of call it in the industry, all hazards. So whether it's a tornado warning, how do we react to that as a community? How do we keep people safe? And really look at all the different pieces we can use. I focus more on buildings, but in a building, we have systems, we have sprinkler systems, we have fire alarm systems, we have other suppression systems, we have rated walls to encapsulate fire into an area. We have, stairs that are rated so that we can get out of the building, safely. All these different components, and they all work together to provide a level of safety for the building, as opposed to one system doing it all on its own. It all works together. And that's really, to me, kind of where the profession needs to continue to go to. And people need to understand all the different tools because our buildings are complex these days. They're more complex than they used to be. The building code, which is a code based on safety, if you read the kind of inception of the building code, it's, to provide a level of safety. The other stuff in a building gets worked out, the aesthetics, the architect, that's driven by market, right? But if the regulatory bodies don't regulate safety, safety ends the drop. That's in any industry, right? So the building code is really about safety, but a lot of times prescriptively, it's written for a square box, so when you try to apply that building code to, the new Guggenheim Museum, or, you're like, what, how does this really work? And so you have to really understand the intent of that safety provisions and how we group all those together and use all the different tools in our toolbox to provide the level of safety we need. So that's kind of what I'm passionate about, and the holistic view on fire protection.
Well, on the code, what are cities like DC and you mentioned Boston? What are they getting right that other cities can learn from?
The way the code's developed. So, New York City, for example, I'm on the code committee. We're in a new cycle now. We've been on a 6-year cycle for the last few years. So New York City jumped. It had a 1938 building code, then a 1968 building code, and then a 2008 building code. So we used the same code, and there was laws and revisions to it along the way, but we had the same building code from 68 to 2008. So we had a whole literally generation that's the code they knew. That's how they built buildings. When 2008 came out, there was so much kind of shock in the industry of, well, we've always done that. Like, yeah, you can't do that anymore. It's different. And, what they transitioned to was New York City started adopting what's called a model building code. So the International Building Code, which is really, if in learning, if you're in architect school, you're going to talk about the International Building Code because it's a model code that is then adopted by most jurisdictions. And New York City does it. Almost all the jurisdictions in the US in some way, shape, or form adopt the IBC, the International Building Code, or the International Suite of Codes. And when they adopt it, then each jurisdiction decides how much that code applies to their jurisdiction, how much they want to change it and modify it. And so New York City had its own code and said, you know what, we're going to shift to the national model. And then they change everything as much, a lot to go, well, we don't do that here. We're going to do this. Each year we did 2008, then we did 2014, 2022. Each year it gets a little closer and closer, and the goal is to, get closer to a national standard. The national standard allows us through different jurisdictions to standardize a little bit, put in practices that other people are using, and then we do it. There is some uniqueness about New York City. It's a lot of high rise. It's different. So we do have to tweak some things to make sure it fits for our city. But when I go to other jurisdictions, they've just been on the international cycle a little bit longer. So they're more ingrained in that. New York City's still stepping. I think, not that New York City's doing anything wrong, but there is a bit of a changing of a guard that's happening over time where, the people that came up and built buildings under the 68 code, now we're starting, 2008 code, we're now out for 15 years on that code. So now you have a generation that's come up starting to build buildings under that style of code, which changes the thought process. And then those become the senior engineers or the senior architects, right, that train the next level, as opposed to, some of the people that I came up with in the city market. 2008 code had just come out, and the senior people that are teaching the juniors that are coming up, they don't know it at all. It's brand new to them. It's an old dog, new tricks, right? So there's different jurisdictions around the country that have kind of just been on that system a little bit longer. But you asked about what's going right, what's going wrong. Again, I'm not going to say New York City is doing anything wrong. I do, as I jump around jurisdictions, there's more prevalence for fire protection engineers in other disciplines. And what I mean by that, if you go look at the licensing exam for a fire protection engineer, it's being able to assess what the risks are and understand what they are, and then understanding all the different systems. You have to know sprinkler, specialty suppression, fire alarm, egress, building construction. All those are part of your licensing exam for a fire protection engineer, as opposed to a plumbing engineer who gets licensed and understands plumbing and may understand the sprinkler side of that, but doesn't understand all of it. So that transition in other areas to where fire protection engineer or people that understand the holistic, I'm not saying you have to have specifically a formal education in it, because the formal education is only certain areas, but understanding and looking at the problems from a holistic view and knowing all the pieces you can use, as opposed to being a fire alarm designer or a sprinkler designer, and they don't even know really each other or how they work. So understanding that holistic view, that's the future to me. And that's what, other places kind of are doing that a little bit more. And we see it more and more. I see it on code committee. There's 5 or 6 fire protection engineers that are kind of, bantering and, trying to get code changes in that make sense from their view, which is a little bit more holistic than sometimes other people that are looking at it from a more narrowly focused area.
What's been the role of technology? We were referring to kind of the 68 code and the 2008 code. I imagine in that time period, and even from 2008 to where we are today, alarm systems, suppression systems have likely changed. Has that had any impact in the latest codes as to how we think about what makes a proper building?
Yeah, absolutely. I mean, the technology is advancing all the time. I think technology in the fire and life safety world advances a little bit differently than in other sectors. And the reason for that actually makes sense when you think about it is that if we're going to rely on something for safety, we really want to make sure it works. We want to make sure it's resilient and can work. And so there's a lot more testing and listings and protocols that things go through in the fire protection, fire life safety world. So, if you wanted to put out a new widget for a BMS system, building management system, you pop it out there, right? And you see how the market reacts. If you want to have a new technical solution for a fire alarm problem, well, you got to go get it listed. You got to go through these tests. You got to make sure it's resilient. Same thing with rain wall. So it's not that fire and life safety doesn't have technology advancements. If you look over the years, it's advanced a great deal, but it's not always, people don't always think of it as quickly advancing, because it has to, you have to have these technologies. Then for it to be prevalent, you have to go through a cycle where the codes start allowing it or mandating it. So you'll see that a lot with kind of emerging things. So, a good example of some emergent stuff in the news all over the place is batteries, right? Lithium ion batteries. You've probably seen it in the news. Fires all over New York City from e-bikes. They're starting to crack down. They have illegal repair shops that they're arresting people. I think we had 200 some odd deaths last year, calendar year, in the city from fires created by these batteries. So it's a new problem. It's a new technology, right? That's kind of unregulated, but now the safety is starting to come in. What are we going to do about that? So I think there was a hearing in Congress, I think it was last week or two, about requiring listings, a listing being an agency that reviews the product and tests the product to make sure it meets certain safety standards, right? The one most people are commonly referred to as UL. So you'll see even on your little power strip that, little UL symbol, it's gone through some testing. So, looking at laws at a national level to require all these batteries to be put through this type of testing to make sure that they're safe. That's a lot of the hazard in New York City is non-listed, non-safe Chinese knockoff batteries that don't have the protection features, that run away, catch fire. You'll see a video online that'll go viral of, someone's pocket vape going, exploding in their pocket, or an e-bike, parked, in someone's apartment that just erupts in a fire. So that's a good example of we now have to have protection technologies. We got kind of through a mandate in the code to put, if you're going to charge these batteries, you have to have an approved cabinet to charge them in if you're going to charge so many of them so that the fire doesn't propagate. Well, that's great. It gets into a regulation. Well, now the technology has to meet that regulation, right? So you got to develop new technologies to meet that. It's got to go through an approval process. It's got to then get code solidified in the next code cycle. So it's not that technology doesn't happen, but to make sure it's safe, we got to do it, we got to do it the right way. And so you'll have a technology emerge, and it may not be 5, 6, 10 years until it's really kind of in the cycle. Even just the code cycle itself. The IBC is currently on a 2024 edition, current year. Okay. But New York City is in their cycle to review and adopt. But because the cycle for that started a couple years ago, we're reviewing and going to adopt the 2021 IBC in New York City. Our last code was 2022, which means we're scheduled to put this code out in 2028. So in 2028, New York City will be adopting a 2021 International Building Code, which was really developed in 2019, 2020. So by the time we adopt, we're already 10 years out. And then technologies, so it's a little bit longer cycle in the fire and life safety world than people are used to in some other areas or disruptive areas of the industry, technology wise.
Are you finding certain sectors have more urgency than others, whether it's commercial, institutional? I'm curious where you're seeing a little bit more urgency to adapt some of the latest in the field.
Yeah, I think that the urgency always comes out of hazard in the life safety world. So the unfortunate thing of how the industry that I work in day to day works is if I go to a building owner, for example, right, and we're designing a building and I go, hey, look, those batteries that you want to put in the basement are very hazardous. We need to do something. Their first question to me will be, what am I required to do? Not what should I do, not what can I do, right? Other areas of the industry, you're trying to solve a problem for something that they need or they want. The building owner, and even the best ones, they don't need or want safety. It's a cost, right? It's an expenditure. It doesn't really help to the public to say, hey, my building's really safe. We promise. They go, okay, whatever. Everyone's kind of ingrained that the buildings that they're in are safe anyway, right? They just think that because we've had building codes for so long, whether they are safe or not, they think they're safe. So there's not much advantageous to putting something on top of code most of the time, right? So that's where you see the most changes, right? So we're starting to see that hazard, and then everyone in the industry scrambling back to that battery example to say, okay, now this is a hazard. People are dying. We got to do something. We got to do something now because building owners aren't going to do it on their own. And that's kind of the history of fire and life safety. We start, nursing homes, for example. I think it was circa 2010s or something. We had a bunch of nursing home deaths in the country. And so they enacted some national requirements to retroactively put sprinklers in all nursing homes. There's a grandfather period. We do that. It takes some time because we had deaths. 9/11 created a bunch of changes in New York City's requirements. One example is a local law that required all high-rise business occupancies to be fully sprinklered by 2019. That was a 15-year phase-in because you can't just pop building owners with this cost right away. And there's still a massive amount of non-compliance with that. But that came out of a tragedy, unfortunately, that then we adopt some new requirements to address that tragedy. And that's really been the fire and life safety game since its origins. Tragedy happens. Oh, we as a public community don't like that tragedy. And so we start putting in ways to fix that. Another big one that was in the news, the Grenfell fire in London. Everyone kind of knew that. It was a facade fire that took the whole bit, something that you're not used to seeing. Wow, holy cow. Look, this whole building's on fire because of the combustible materials used in the exterior of the building. So then we go and we're off on a tear to try to, adopt codes. There was actually some requirements already out there for many years, but no one was adopting them in their jurisdictions and using them. So then it starts to really flush out that we have to do something about this problem. And that's really the industry. And I didn't answer your question, but your question was more, is there a specific occupancy? So it's really, it emerges out of that. Right now, what I'm seeing you see a lot of warehouse fires because we've changed the way we deliver to people, right? I've worked on, the new Amazon facility, storage facility, right? Because we now expect everything in a day. I get annoyed when I go on my phone. Like it used to be 2 days, it was like, holy cow, this is amazing. Now I'm like, what, I can't get it tomorrow? That's why am I not getting it tomorrow? I want the 7 a.m. one tomorrow morning. I need this right now. So now we're building out these storage facilities and distribution facilities. A new one's going in Queens and one in Staten Island that it used to come from maybe a more remote area. Now they go, well, we got to get it closer to the source if we want to hit that that speed. So now we're putting these large warehouses. I've done a warehouse that a lot of these use robots now. So we got stuff that would never have occurred before. The robots move these extremely densely stacked pallets of products that are combustible. The clearance to the ceiling is a quarter of an inch because it's so digital and amazing and compact, and these robots can smash everything in. But now I'm going through a warehouse. There's no aisles in the warehouse. There's nowhere to walk. It's this robot contained big fire hazard that we have to figure out how to protect. So that's where I'm seeing a lot of this stuff is those type of, it's a reaction to what we as a public want, right? What do we need? What do we want? We want stuff quick. We need warehouses. This industrial side thing is blowing up, the batteries, all these things that power what you and I do every day. That's the next thing that we have to address in the fire life safety industry.
You've alluded to a variety of things. That you use the London example of combustible material on a facade. You've talked about robots and lithium batteries. A lot of this, which I presume is kind of outside of the typical scope of what you would need to work on in part of the design, which suggests like kind of a multidisciplinary approach. How do you think about that when you have to, in some ways, be reactive to the decisions that other design consultants are making? I mean, how do you square that circle, and how do you even begin to have these conversations with designers working on brand new buildings or retrofits?
It's a good question. If I'm on a project team, right, I'm trained into understanding these things that could be potential hazards and looking at them, but it's not often how we approach a project, right? I get scoped for a specific hazard or a specific thing. I'm not getting all the information, right? I come into projects late a lot of times where they go, hey, we just found out we can't do X, what can we do? I'm like, well, you could have called me a year ago and then I would have helped you out and we would be at a lot better spot. I did a theater where they were just doing a facelift, but all the seats were all torn up. So they're going to put all new seating in. When they did it, they plopped in some new seating that was a little bit tighter than the old seating. Well, the code allows that, but you have to have a smoke control system. They didn't find that out until after it's almost all done. And then to get approval, they go, oh, well, your seating's too tight. You need a smoke control system. Okay, what do we have to do for that? Well, unfortunately, you're in the city, your theater's under a high rise, so it's not exactly easy to put a mechanical system in to get everything out. We don't even have a mechanical engineer on the team because it was just a facelift, right? It can be very complex and multidisciplinary, and everyone works in their silos a little bit. I use the term silos a lot. It's not to be offensive, but you look in your scope, and then when you are very aware that your scope touches another one, you'll reach out, right? Hey, we're doing this thing. We need electrical power for it. I'm going to reach out to the electrical engineer, let him know that we're going to put in this fan, whatever. But, the owner says, hey, for the systems we're doing in this building, we want battery backup. We want a UPS system. They're going to procure that on their own and they were going to install it on their own. Well, they didn't inform the architect, the engineers, right? So then they go to put it in and all of a sudden, well, you need ventilation for the room that it's in. That's not spec. We need sprinklers for the room. We need detection for the room. Oh shoot! Why? Well, why does my thing affect it? Because everyone's kind of knowledgeable about their little specific discipline, but no one's looking at it holistically. To some extent, the architects do try to look at it holistically. But if you're an architect that is trained in, something that your focus is whatever it is, aesthetics. I was listening to one of your other the look, the smell, the feel of the environment. That's what you're engaged in, right? And the safety is just that's a requirement. We'll have to make sure we meet it. But you're not looking at it through that lens. That's the only lens I look at it through. So people will ask me, how do you know that? Well, that's all I do. That's my profession. That's what I do. I don't know why you think that things should look like that. That seems foofy to me. I don't know what you're doing, you architects, but I know this part, right? So I think it's a big challenge on projects, especially as they get more complicated, more complex. We get into this digital world where communication's a little bit different. It's easy and it's hard all at the same time, right? We set up, in our project teams, and we have these collaboration methods in our project teams. But then there's all these sub teams within a project team, right? So, the MEP engineer, they're using Slack, and that's how they communicate and they share documents. And then you go over to the structural engineer, and oh no, we're on Google Meet. That's what, this is a great platform. And you'll hear all these people running companies, leaders going, we're on this platform. It's great. It's robust. It does everything we need so our team can share. But you also have to work with the electrical people, and those guys are on a different platform. And then you got to work with the construction team. They go, oh, well, we use Procure for everything. Well, I don't even have a login for Procure. So how am I going to get you the information? So we're in this weird digital age where the common ground used to be the conference room or the, hey, we're going to have a charrette here at the architect's office, and all the trades are going to come in and sit in a room. And now we're trying to get it all. And I don't have that document. It's a very different world. There's a lot of benefits to it, but there's also a lot of challenges, especially when you start taking multiple teams and trying to work together. And I find that it inhibits us sometimes because you're on a different platform or on a different thing that we don't do it. I've found since the pandemic that getting people to site meetings, which was very commonplace when we were all sitting in the city in our offices. Hey, let's go meet on site. No problem. Hop on the subway, go over. Well, now my structural engineer, who used to live in the city, now lives in Connecticut. He's like, do I really need to be on site? Can I just call in? My mechanical engineer, well, they relocated to Colorado. Didn't really tell anyone, but they're still part of the New York City office, but they're in Colorado. So hey, can you come meet quick? I work out of my home office. I'm out on Long Island. I still go into the city all the time for different meetups, but I'm trying to meet with someone and I go, oh, well, I'm actually not local. Oh, okay. And that's a benefit, right? You can grab these people with intellect and capabilities from all over the world to work on a project in New York City. But when we got to go wire it all up and get in the room together, it's a little bit harder sometimes. So one of the hazards of the kind of new age remote work technology, I'm not saying we should go back to what we were, because I think there's a lot of benefits of how we're operating now, but it's definitely a challenge that I don't think can be overlooked, especially when we're building something in a physical environment. And I think that's what people forget. I had a staff of almost 200 in my last position, and people, well, my friend, they do this. I'm like, well, your friend works for Facebook, which is very digital. There's not a physical thing that they're, building. So yeah, that makes sense that they're allowed to work for, well, why can't I work from? Well, most days you're fine, but then there's other days where we need to be at the physical thing that we're trying to design, construct. We talked about earlier existing conditions, right? I mean, how many times the person that's designing has never been to the building that they're designing something for? My first thing I always go, I need a site visit. Do you really need a site visit? We have the drawings of the building. Well, yeah, I need to see it. I need to visualize. I need to understand. You might not be giving all the information to me because I'm only getting what you filtered and think I need. I need to go and absorb the information. And especially existing buildings that I work on all the time. You have to see it, you have to feel it, you have to understand the building to even understand what you might run into as challenges. So it's a different world, and it's definitely difficult.
You alluded to how fire safety is often seen as kind of an add-on or an afterthought. Are there examples of projects either that you've worked on and that you've seen completed recently where it didn't feel like a kind of an add-on, but rather like part of a kind of a holistic approach to putting together a building, where it wasn't just kind of the bare minimum?
Yes, to some extent. So the projects that I would say run the smoothest in my fire and life safety bubble, right, are ones where they're engaging someone like myself or a peer of mine at an early stage to say, this is what we're doing. Tell us what we should be thinking about, very early on. Because a lot of teams wait till there's an issue that they encounter to then, bring it in. And most of my stuff is when there's an issue and then, we have this big issue. I don't know if I'm like, yeah, that's all I deal with is issues. But there are projects that start in it. And I'll tell you, those projects almost always are run by initiative as someone that got burned on the last project, right? So they go, you know what? Our last project, I worked with like a healthcare architect, did all healthcare, very specialized. And they called me we botched this. We didn't put in a stair when we needed one. What do we do? And I was able to help them out. I was like, you need this, but there's this equivalency process. And you actually, if we do this and this, you actually inherently installed some stuff that's a little bit higher than code. So we might be able to use it, and got them through it. And they said, going forward, I've instructed all of our project managers that before we start a project, we're calling you and your team to get on the project. And that may be 2 hours worth of work to just go, yep, you're on the right direction. Call me again in a month. And sometimes go, whoa, watch out for this. So I think similar to the rest of the industry in fire and life safety, once an incident happens, then we all react. Once someone's got burned or been on a project where they got to the 11th hour and they weren't able to get their building approved, they didn't realize that, or the owner needed UPS battery backups and everything was designed to put that in the basement, and they go, you're not allowed to put them in the basement? Who said that? Dang it. That's when then the next time they engage me. So I have ones, and I do have, owners and that really actually think about the safety of their building and say, I know it's not required, but what's the best practice? What can we do? If I care about, the safety of the patrons, I love working for those clients. Few and far between, though, to be fair. So
Yeah. Give me a sense of starting a project in 2024. Like, what are the absolute must-have ingredients, right? And by ingredients, I mean, like, you have, again, the various things you have to consider, from alarm systems, sprinkler systems, suppression, et cetera. Like, what are the absolute must-haves in a building in 2024 where you just absolutely have to consider?
So the building code does a good job prescriptively of at least kind of walking you through, okay, what's your occupancy? And you really have to start from the beginning. A lot of people, and this is one of the things I hate about the digital age and some of the junior staff, is word search, right? So the building code, open up the building code, word search for whatever you think, battery or whatever it is, and then it pops that section. It's not really how the building code works. I came up in a paper thing with tabs, and you start, and I instruct everyone, first and foremost, have you ever read the definitions section? It's really mundane, right? But the forefront of the building code has a whole chapter on definitions, and it defines all these things, and it may define it in a different way than you're used to or colloquial speak about things, right? So, I did a presentation yesterday on life safety systems, new definition in the code in 2021, because no one had put it in, where everyone thought it was inherent. What is a life safety system? And one of the things it talks about in that definition is things that help people egress or exit out of a building. So you wouldn't think of a life safety system. Your head pops in as an architect or in that trade as a fire alarm system, maybe a sprinkler system. What if I told you the egress system, the stairs, the ramps, the corridors, that's part of a life safety system? I wouldn't think about it that way, right? You start at these definitions, start understanding what the code is trying to do. So in a new building, you kind of start at the beginning. What occupancy type are you? But then you're going to have probably multiple occupancies in that building, to be fair, right? We don't build just a business building, just a residential building always has retail at the bottom, right? So now it's a multi-use building, especially in this stage, office retail. What are we doing? We're flipping things over and going, well, there's going to be, it's an office building. The third floor is going to have an escape room. Like, okay, that's not office anymore. Oh, what is that? What do you mean? Like, they're just taking one of our office suites. Okay, well, that's a different type of occupancy. So you start looking at these things. I would say if you're not trained in it, it can be difficult, right? And it can feel like you're spinning your wheels. One of the things as kind of a code consultant we do on a lot of projects is a code compliance approach report or something of that terminology, depending on where you are in the country. And to me, it almost seems mundane. It's very, very simplistic. But if you're not familiar, it's someone going through and saying, this is what you want to do in concept, and someone going through and literally writing out the different sections of code that might be applicable, the different things you might need to consider. It'll be a 5-page, 10-page document that then can get updated as you go through the project, as things change, as an owner requirement comes in. But that's where we always start in the fire and life safety world, is concept design. We're going to do this code compliance approach report, something of that nature. So we've kind of just stepped through very basically, before it gets even challenging to how we're going to accomplish it, just what is it that we have to be considering here and really looking at it with that broad lens. And too many projects wait until they're in design development or construction documents to start addressing those things and don't really start with that basis. I mean, I've definitely consulted with a good handful of project leads, architects, what engineers go, well, it's just basic code. We got that covered. It's the weird stuff. And I go, okay, you got the basic stuff covered. But do you really? Have you looked at all the different basic stuff to really get you going? That's where I start is, really looking. If you read a section of the code and you don't understand what's the definition of the words in there, go back, oh, that means this. Okay, that's not really what it means. Yeah, it is. In the context of this document, in this building code, they define that as this. And you should see, you sit in a code meeting and we're going back and forth on the definition. We did one, I had a code meeting last week. We were going back and forth on a definition for 45 minutes. The exact words and where the commas go to really make sure that the users of this document understand this is what we mean by this terminology. What is a battery system? That's simple, right? It's about no. Battery system means, and there's a chapter on what that means. So that's my advice to anyone is kind of where to start. Understand is go back to basics. If you think just forget it. Just go read it again. I do it. I still do it. I'm a profession. I will still. My wife's in this profession too. That's what we do. We go back. If you read this definition, maybe that's not what they meant. And then I'm going and researching what exactly that definition means. So start at the top of the page and work your way down. It can be mundane, but that's kind of where you got to start on these buildings.
In 5 years from now, 10 years from now, when we're walking into buildings and presumably we've been proactive about adopting the right life safety systems and we've done everything that we should be doing, what does the experience look like in 10 years when you're within a, for example, commercial building? What can we expect?
I think you can, if everything's going right, you can expect it to be out of sight, out of mind. No one knows. I think it's like, these things really are designed, the intent is to work in the background, right? That they're almost inherent. That's the way, we want it from an aesthetics point of view, from an everything. You just don't even want to know it's there. I did some retrofit designs on existing buildings for sprinklers where you wouldn't even know they're there. There's, it's the Capitol building has sprinklers in it that no one's ever seen because you got them custom painted to match, to blend in. We specifically spaced the sprinklers, in little spots on the artwork so that you can't tell they're there, right? It's, I think that's where design wants to be for these things, because the reality is the architect you had on a couple of weeks ago who's talking about design aesthetics and all this stuff, right? And the feeling of the space, guess what? None of them want the feeling of the space to be sprinkler systems, fire alarm systems, right? Like, how can we hide this? And that's fair, right? Like, that's not the experience. There are certain occupancy types, that more industrial, we don't care to hide them, but also they can be a benefit of seeing them because people feel a little bit safer knowing that there's stuff there. It's actually one of the things in the code too. If you have a system that, say, you decommission, you actually have to take it out because you can't have the public think that there's a system in there that's going to keep them safe if it's not working. So if you're going to, replace an old sprinkler, a good example is the like alarm bells throughout a building. We'll put in a new fire alarm system. You still see the bells there. Well, you're actually supposed to take the bells out because people see them and think that they're going to do something. And, oh, no, those have been disconnected for a decade. Well, then you got to take them out because the public thinks that they're going to do something. So I think, the buildings of the future are going to continue to integrate the life safety, into it. And really, you only know that they're there when they need to be there. But that's also the hazard of life safety systems and why I personally work to integrate the life safety systems with other systems that we're going to use anyway. And there's a reason for that. So, I did a museum recently where I pitched to the museum. They had a great public address system, right? They have to announce things, museums closing in 15 minutes, right? So they have this high-end speaker system that talks to everyone. And then right next to it, we're going to put in a fire alarm system with kind of, to be fair, some low quality speakers. So, well, one, we can save you some money. You're actually allowed to use the fire alarm system. It's hardened. It's more robust than a PA system. You can use it for public announcement. A little bit difficult to get the fire department to agree to that because they're not used to it, but we got it approved. And now, why do I want to pitch that? Well, we upgrade the fire alarm system quality a little bit. That's not a bad thing. We allow it to use for public address. But guess what? If that system doesn't work for one day, we'll know it and we'll fix it, because they can't operate daily without that system working. Now, the fire alarm system stops working and it beeps a little bit. We'll get a technician out next week. We'll take a look at it. Not a big deal, right? We don't use it every day. So anytime we can integrate something that we use every day and fire and life safety together, I think that's the best way to approach things in the future, just because it gets used more, right? Smoke control, I always say when we're doing smoke control, which is using the HVAC system, most of the time it's a mechanical system to exhaust smoke out of a space, keep it safe for occupants to get out. If it's a smoke control system, guess what? Day one of office building opening, if it's too hot or too cold, they're there right away, right? And like, oh, something's broken, it's not working, it's 80 degrees in here. Smoke control system doesn't work. Would you ever know? No, right? The only time you're gonna know is when it doesn't work. There's requirements for 5-year testing on smoke control systems. Most buildings are not compliant with that on a regular basis. So, jurisdictions are starting to go write them up. Hey, you didn't do your smoke. What do you mean? It's fine. It's been there, because they don't have to do anything with it. So anytime we can kind of use systems for dual purposes, it's something I'm an advocate for, because it just keeps it front of mind, and so that we're always using it.
And this has been an incredible session. I think this is the necessary primer that I needed to hear, right, on life safety. So before we wrap, for folks that want to follow along with your work or even reach out to you, where can they find you?
I'm on LinkedIn. I'm not a big social media guy for other things. So I'm on LinkedIn. You can always reach me there. My website, FLINT, FLINTFE.com. And, my contact info is right on there. Reach out. Happy to help. Like I said, engage at an early stage for a few minutes here and there can go a long way in the long run of your building.
Awesome. Brandon, thanks again.
Thank you.